Hi students, this is Alex here. In the video, we will chemistry practicals.
Good morning students. I am Mrs. Isabella, working as chemistry PG assistant in St. Vincent's Matriculation Higher Secondary School. In this video presentation, we are going to learn about volumetric analysis, which is the standard 12 practical portion. Now the word analysis means to find out, and volumetric is to measure the volume. Therefore, in volumetric analysis, we are going to find out the concentration of a given solution by measuring the volumes of solutions which react with each other. Concentration of a solution is nothing but the amount of substance present in a given definite volume. There are different units of expressing concentration. These units you have learnt in standard 11. Some of them are normality, molarity, mole fraction, etc. Here in volumetric analysis, the concentration is going to be expressed in terms of normality. Normality is given by the formula weight per liter divided by equivalent mass. So in volumetric analysis, we are going to find out the normality of a solution. This is done by means of a procedure called as a titration. A titration basically involves three solutions. One, a standard solution whose normality is given. The second one is an unknown solution whose normality we are going to determine, and the third solution we call it as the link solution. So making these three solutions, we are going to find out the normality of the given unknown solution. For this titration procedure, we will be using an indicator. An indicator is a substance which is used in a titration procedure, which will help us to indicate the completion of a reaction with the help of a visible color change. There are several indicators which can be used in a titration procedure. So today we shall learn the first experiment of volumetric analysis, the estimation of ferrous sulphate. We are going to estimate the amount of ferrous sulphate dissolved in 750 ml of the given solution volumetrically. For this, we have a standard solution of ferrous ammonium sulphate of normality 0.1102 N and potassium permanganate as the link solution. So as you can see here, the standard solution is ferrous ammonium sulphate whose normality is given as 0.1102. The link solution is potassium permanganate and your unknown solution is ferrous sulphate. So we have to determine the normality of ferrous sulphate and the weight of ferrous sulphate present in 750 ml of the given solution. Now the principle involved here is a redox reaction. A redox reaction can be written as two half reactions, the oxidation and the reduction. For the oxidation reaction, ferrous sulphate is oxidized to ferric sulphate. So you can see here Fe2 plus is losing 5 electrons to be oxidized to Fe3 plus. So this is the oxidation reaction. Under the reduction, we have the potassium permanganate, the KMNO4 is going to be reduced to the manganese ion, that is Mn2 plus. The electrons which are lost by the ferrous ion, they are gained by the permanganate ion. Adding the two reactions, we have the overall reaction Fe2 plus combining with MnO4 minus in the presence of an acid medium to give you Fe3 plus and Mn2 plus. So this is the overall reaction. This is the principle involved in the reaction. Now for our practical procedure, we have to learn this short procedure what we are going to do is actually a double titration. There are two titrations involved, titration 1 and titration 2. For the first titration, in the burette we take potassium permanganate. The pipette solution will be 20 ml of standard ferrous ammonium sulphate. To it we add 20 ml of 2N sulfuric acid because the reaction is done in the acid medium. The temperature will be the lab temperature, and in this particular reaction we do not add an external indicator but potassium permanganate, it acts as a self indicator, and the end point will be appearance of a pale permanent pink color. For the second titration, all the other points will remain the same. In the pipette solution alone, instead of the standard ferrous ammonium sulphate, we take 20 ml of the unknown solution of ferrous sulphate. Now let us see how to do this experiment using the pipette and the burette. First step in the titration procedure, you rinse the burette with water, and then the burette is rinsed with potassium permanganate solution, which is the burette solution. So we rinse the burette with a small amount of water. And then it is rinsed with a small amount of the burette solution, which is your potassium permanganate. After which we use a funnel and the burette is filled up till the 0 level. So this portion, the tap of the burette should also be filled with the solution. So it is filled till the 0 level, which is on top, and it is placed on the burette stand. Now while filling the burette, care should be taken that there are no air gaps, and the second precaution, never add the solution with the burette on the stand. So don't keep a funnel here and add the solution directly, because the solution is very dangerous to the eyes. It may accidentally splash on the eyes. So never add the solution by keeping the burette directly fixed to the stand. The second step will be you wash the conical flask thoroughly, and we use a pipette. The volume of this pipette is 20 ml, and we can see the graduation here. So this marking which is present here indicates the 20 ml marking. So the volume of this pipette is 20 ml. Now your pipette solution, you take the pipette solution, introduce the pipette into the pipette solution and suck from the top, and the level should be up till this line. So hold one end of the pipette with your finger, gently release it such that the level is on the line. So for a colorless solution, we will be following the lower meniscus. That means you can see a small curved portion that should touch the line, after which it is transferred into the conical flask. Now while transferring into the conical flask, the last drop which is present in the pipette should not be tapped against the conical flask or blowed from the top. So gently release it and wait for 1 second until the entire solution drains out. As the reaction is done in the acid medium, we add a test tube full of sulfuric acid. whose normality is 2N. It is a dilute solution of sulfuric acid. Now keep the conical flask under the burette. There is a white tile which is present here such that the color changes can be seen properly, and the tap of the burette is slowly opened. So you hold the conical flask with your right hand and the tap of the burette gently with 2 fingers of the left hand and open it in the downward direction. When again you want to close the tap, it is closed once again in the upward direction. So release the solution from the burette gently, and at the same time the conical flask is swirled. Now when the reaction is completed, the color will change to a pink color. So this is your end point. At the end point we will get a permanent pale pink color. So care should be taken that we do not add too much of potassium permanganate, otherwise the color will be too dark. So this is the end point, the permanent pale pink color. Now to read the burette reading, the burette is removed from the stand. You keep it to your eye level and note down the reading. Now the burette is graduated from top to bottom. So we can see that the 0 ml is present on the top. So therefore here when we read this burette reading, we have 19 ml which is present here, and the reading is in between 19 and 20. So it is at the 5th division. Now as we are reading the burette from top to bottom, this reading should be read as 19.5. So the burette reading, we read it as 19.5 as the burette is graduated from the top to the bottom. So note down the burette reading, and the burette reading is entered into the tabular column. After which the contents of the conical flask, they are thrown out into the sink. Wash the conical flask thoroughly. Repeat the same experiment using the same solutions. We should get concordant values. Now concordant values means the immediate 2 trials, trial 1 and trial 2, the values should be the same. So that is what we call as concordant values. So note down the concordant values in the tabular column. This is the first titration, titration 1. So we have completed the first titration. So in the first titration we had taken potassium permanganate in the burette and ferrous ammonium sulphate was taken in the pipette. So that is your first titration. Now for the second titration, the burette solution will remain the same. Instead of taking ferrous ammonium sulphate, we take the given unknown ferrous sulphate in the conical flask. The procedure, etc., everything will be the same. Only difference will be, we will be taking ferrous sulphate in the pipette and transferring it into the conical flask. Repeat the same procedure of the titration and record the concordant value for titration 2. Enter the values of titration 1 and titration 2 in the tabular column. Let us now see the calculations, how we are going to determine the normality of the unknown solution. Now titration 1, we had done link potassium permanganate versus standard ferrous ammonium sulphate. So the volume of standard ferrous ammonium sulphate is 20 ml, which is your pipette solution volume. The burette reading initial value is 0 ml, the final value is 19.5, and hence we have the concordant value is 19.5. So this is what we mean by concordant. The first and the second values both should be the same. Now writing it out here, the volume of potassium permanganate V1 is equal to 19.5. The normality of potassium permanganate N1, the link solution, it has to be determined. The volume of standard ferrous ammonium sulphate V2 is 20 ml, that is the volume of your pipette solution. The normality of standard ferrous ammonium sulphate 0.1102, 0.1102N, which is already given in the question. So V1N1 is equal to V2N2. This is the law of volumetric analysis. Now according to this law of volumetric analysis, when two solutions are reacting with each other, if their normalities are the same, the volumes in which they react will also be the same. Therefore, we have N1 is equal to V2N2 by V1. Substituting these values here, so your V2 was 20 and your N2 is 0.1102 and your V1 value is 19.5. So we get 0.1130N. Now this is the normality of the link potassium permanganate solution. Now we shall move over to titration 2, wherein we have link potassium permanganate solution versus the unknown ferrous sulphate solution. So again, filling in the tabular column, the volume of the unknown ferrous sulphate solution, the pipette solution volume 20 ml, the burette reading initial will again be 0, the final reading 20.5. So for the first trial and for the second trial, we get 20.5 and hence we say that the concordant value is 20.5. Substituting the values here, the volume of unknown ferrous sulphate 20 ml, its normality we have to determine, the volume of the link potassium permanganate, the burette reading which is 20.5 and its normality which we have already determined here, 0.1130N. Making use of the same law of volumetric analysis, V1N1 is equal to V2N2. So N1 is equal to V2N2 divided by V1. Substituting the values in this formula, we get the normality of the unknown ferrous sulphate solution as 0.1158N. Therefore, we have found out the normality of the given unknown ferrous sulphate solution as 0.1158N. The last part of the calculation will be the weight calculation. Here the formula is the amount of ferrous sulphate dissolved in 1 liter is equal to normality into equivalent weight. So this is the formula, normality into equivalent weight. Now we need to calculate the amount of ferrous sulphate in 750 ml is equal to 0.1158, which is the normality of ferrous sulphate, into 278, which is the equivalent weight of ferrous sulphate, into 750 by 1000. This, when you simplify, it is into 3 by 4. Calculating this value, we get the answer as 24.14 grams. Therefore, this is the amount of ferrous sulphate which is going to be present in 750 ml of the given solution. Therefore, we have learned in today's experiment how to determine the concentration of the unknown solution. So that was the first step. We determined the concentration of the unknown ferrous sulphate solution in terms of normality, which was found to be 0.1158, using which we have determined the amount of ferrous sulphate in 750 ml, which is 24.14 grams. So this is the final answer of the experiment. We have seen in detail the first experiment, the estimation of ferrous sulphate. Now there are remaining 4 more experiments in the practical syllabus. Now all the experiments have to be done and the calculations are all exactly the same. So what will only change will be the pipette solution and the burette solution. Now this pipette solution, burette solution, it is given in detail in the simple procedure. So you can first read the question, identify which is the standard solution, which is the link solution and which is your unknown solution. You can use the simple procedure given in the textbook as a reference and accordingly it has to be done. So the procedure is the same, the experimental part, how you fill the burette, the pipette, and the calculations, everything will remain the same for the first 3 experiments. Now in the last 2 experiments which are there, we have what is called as acidimetry. The first 3 experiments, they come under permanganometry. That means potassium permanganate is used as your burette solution. The last 2 experiments are called as acidimetry, wherein you are going to use an acid and a base. For these 2 titrations, an indicator will be added externally, and accordingly there will be a color change. So an indicator, for example, either methyl orange or phenolphthalein is added externally, and according to it there will be a color change which is given in the short procedure. So you can follow the short procedure which is given in the textbook, and the method what we had seen now for all the remaining 4 experiments.
மேம் இப்போ கெமிஸ்ட்ரி ப்ராக்டிக்கல் பண்ணும்போது என்னென்ன மிஸ்டேக்ஸ்லாம் லேப்ல பண்ணக்கூடாது?
Let us see some of the mistakes which you should not perform while doing the volumetric analysis. Now the first one, as I told you, always fill the burette having the burette in your hand. Never fill the burette by keeping it to the stand, as most of the chemicals which we use in the lab, they are dangerous. If it falls on your eyes, it will lead to a number of problems. So always fill the burette solution keeping it in your hand. The second one, when you read the burette reading, read it from top to bottom. So do not make a mistake in the reading of the burette values. The burette values will be read from top to bottom. That is the second one. The third one, when you fill the pipette. So as I told you, the last drop of the pipette solution, you must not blow or tap the pipette on the sides of the conical flask. So wait gently for 1 or 2 seconds for it to drain out, and that will be 20 ml. So don't blow or tap the last drop which is present in the pipette. And when you come to the simple procedure, the simple procedure is almost the same for the first 3 experiments. Only your burette solution and your pipette solution will change. So read the question twice, identify which is your standard solution. Now it will be mentioned there in the question itself, which is the standard solution. So the standard solution for which the normality will be given, and it will also be mentioned to estimate the amount of. So the solution which comes after that is your unknown solution. So the solution which is coming after that to estimate the amount of will be your unknown solution. So and the link solution also will be specifically mentioned. So read the question, and accordingly the simple procedure will be written. Now when you are doing the calculations, you may get a confusion as to what is V1, what is N1, how you should take it. So remember that always the V1, N1 will be for the unknown solution. That means for which we are finding out the normality, and V2 and N2 will stand for the known solution. So identify these solutions, and when you do the calculations, as I told you, V1 and N1 will stand for the unknown solutions, V2 and N2 will stand for the known solutions.
மேடம், நிறைய பேருக்கு கெமிஸ்ட்ரி ப்ராக்டிகல்ஸ்னா கஷ்டம் அப்படின்னு சொல்றாங்க. ஆக்சுவலா இது கஷ்டமா ஈஸியா? ஈஸி அப்படின்னா என்ன வேலை இது ஈஸி? ஸோ எப்படி ப்ரிப்பேர் பண்ணா ஸ்டூடெண்ட்ஸ் வந்து இதை ரொம்ப ஈஸியா ஃபீல் பண்ணுவாங்க?
Now the volumetric analysis of standard 12 is much simpler when compared to the physics experiments, etc. Now the reason is, as I told you, if you know the procedure which is involved in one experiment thoroughly, the procedure and the calculations, all the experiments will follow the same method. So only your pipette solution, the burette solution, and in the last 2 experiments, the 4th and 5th experiment, the indicator endpoint will change. Otherwise your calculation, the volume of the pipette solution, normality of, so all that calculations will be the same. So one experiment, if you are very thorough, all the experiments they follow almost the same pattern. So therefore the chemistry practicals is much simpler when compared to the other subjects. Okay students, so study well and all the best.